Three major solar flares erupted from a single sunspot yesterday in approximately 10 hours, the strongest of them an X1.0, and two of the three coronal mass ejections that left the sun have been confirmed Earth-directed. A third is inbound. The published NOAA forecast says geomagnetic conditions will stay quiet through Friday. The discussion text behind that forecast says, 3 separate times, that the modeling is still ongoing. By the end of this report, you'll understand the gap between those two documents and what it means for the next 48 hours. Yesterday, in a span of approximately 10 hours, a single sunspot on the surface of the sun produced 3 major solar flares. The region responsible, designated by the National Oceanic and Atmospheric Administration as Region 4455, is currently located at heliographic coordinates north 14 degrees, west 20 degrees on the visible solar disk. The first event was an M9.3 flare, which peaked at 1:36 universal time. The second was an M7.7, which peaked at 700 universal time. The third was an X1.0, which peaked at 11:28 universal time, and which produced an R3 strong radio blackout, the highest radio blackout classification reached in the past several days. Each of those 3 flares produced a coronal mass ejection. 2 of those CMEs have now been confirmed through triangulation with the Stereo A spacecraft on the opposite side of the Sun from Earth to carry an Earth-directed component. The third, associated with yesterday's X1, was still inbound to the LASCO C2 coronagraph field of view at the time the NOAA Space Weather Prediction Center issued its midday forecast. By the time you are watching this report, the third CME has been imaged. By tomorrow morning, all 3 will have been modeled. The radio signatures from yesterday's 3 events give us a clear picture of how the eruptions evolved. The M9.3 was accompanied by a 10.7 centimeter radio burst, peaking at 360 solar flux units. The M7.7 was accompanied by a 10.7 centimeter burst, peaking at 540 solar flux units. The highest of the 3 bursts of the day, along with a Type 2 radio burst with an estimated shock velocity of 313 kilometers per second. The X1 was accompanied by a 10.7 centimeter burst, peaking at 250 solar flux units. The shock velocity from the M7.7 tells us that the eruption was strong enough to drive a magnetohydrodynamic wave through the surrounding coronal plasma. Strong enough, in plain terms, to push the solar atmosphere out of its way as it left. What you need to take away from the chronology is this: 3 major flares from 1 sunspot in 10 hours. 2 confirmed Earth-directed CMEs already on their way. A third inbound. And the published forecast that NOAA issued yesterday afternoon contains a caveat that the headline does not. Region 4455 is doing something that almost no sunspot in the current solar cycle has done. It is what solar physicists call an anti-Hale region, a sunspot complex whose magnetic polarity is reversed relative to the dominant orientation for its hemisphere during the solar cycle. In 1919, an American astronomer named George Ellery Hale wrote down the empirical rule that has carried his name ever since. In each hemisphere of the Sun, during each 11-year solar cycle, the leading polarity of bipolar sunspot pairs is consistent and reverses in the opposite hemisphere. Then, 11 years later, when the next cycle begins, all the polarities flip. We are currently in solar cycle 25. In cycle 25, the leading polarity in the northern solar hemisphere should be positive. About 97% of the sunspots that have emerged in this cycle have followed that rule. Region 4455 does not. The mature positive polarity spot at the center of the region is consistent with Hale orientation, but a series of small negative polarity spots have been emerging through the photosphere, south and west of the mature spot. And those emerging spots are oriented in a reversed configuration relative to what the prevailing field would predict. The NOAA Space Weather Prediction Center, in its public discussion document, characterizes the region in this language. Quote, Region 455 remains complex, displaying an anti-hail configuration caused by a series of small negative polarity spots developing south and west of its mature positive spot. These spots exhibited continuous flux emergence, causing a very mixed polarity area with substantial shear, likely the source of the high-level M-class flaring from that region. End quote. The reason that matters for the next 48 hours is statistical. Published research, particularly McClintock and Norton in 2016 in the Astrophysical Journal, and Munoz Jaramillo and colleagues in 2021 in the same journal, has established that anti-hail regions, despite comprising only 3 to 5% of the bipolar sunspot population, produce a disproportionate share of major flares. The physical mechanism is enhanced magnetic shear. When new flux emerges into an anti-hail region, it has to accommodate the mismatch between its own polarity tilt and the surrounding dominant field. That accommodation produces persistent shear along the neutral line, separating the positive and negative regions. The sheared field stores magnetic energy. When the configuration becomes unstable, the field reconnects, and the resulting flare is on average more energetic than a comparable flare from a hail-compliant region. Region 455, producing 3 major flares in 10 hours from a confirmed anti-hail configuration, is in the upper tail of anti-hail flare productivity, but it is consistent with the statistical pattern. It is not an outlier event in physical terms. It is the kind of event that the published flare probabilities, calibrated to the full sunspot population, tend to underestimate because the anti-hail subset performs above the baseline. SWPC has assigned Region 455 a 40% M-class flare probability and a 10% X-class flare probability over the next 24 hours. The anti-hail literature suggests both numbers are conservative for an actively flaring region in its current configuration. There is a third piece of yesterday's solar activity that has not yet been mentioned, and it is the piece that may matter most for what arrives at Earth. On Tuesday, June 2nd, a large filament eruption occurred from the southwestern quadrant of the visible solar disk. The filament itself was not Earth-directed. NOAA's Space Weather Prediction Center modeled the eruption and confirmed that the resulting coronal mass ejection was moving outward in a direction that did not point at Earth. By itself, the filament would have been a footnote, but the filament is now in interplanetary space between the Sun and Earth, ahead of the 2 confirmed Earth-directed CMEs from yesterday morning's flares. The filament-driven CME is slower than the eruption-driven CMEs behind it. The faster CMEs are catching up. This is the textbook geometry of a compound coronal mass ejection. SWPC's discussion text addresses the geometry directly. Quote, modeling of a large filament eruption from the southwest from earlier in June second confirms no Earth-directed component. However, its timing, source location, and relatively slow velocity mean that it has a high probability of interacting with the faster CMEs behind it and changing their propagation into the near-Earth environment. End quote. What that means in operational terms is that the 3 Earth-directed events from yesterday may not arrive at Earth as 3 independent disturbances. They may arrive as a single merged structure. The merger physics has been studied since the early 2000s, and the canonical reference, Liu and colleagues in 2014 in the Astrophysical Journal, established 2 findings that are directly relevant to the next 48 hours. First, compound CMEs are disproportionately responsible for major geomagnetic events. Across solar cycle 23, approximately 40 to 60% of G4 and G5 geomagnetic storms were associated with compound CME structures rather than single CME arrivals. Second, compound CMEs are substantially harder to forecast than single CMEs, because the merger geometry depends on parameters that are not directly observable from Earth's vantage point. The headline forecast that NOAA issued yesterday afternoon does not and cannot yet incorporate the compound interaction physics. The modeling for each of the 3 Earth-directed CMEs was still in progress at the time the forecast was published. The compound interaction with the June 2nd filament adds another layer of modeling that has to be completed before the forecast can be revised. The phrase "modeling is still ongoing" appears 3 separate times in the NOAA Space Weather Prediction Center's discussion text from yesterday. It appears in reference to the M9.3 CME. It appears in reference to the M7.7 CME. And it appears implicitly in reference to the X1 CME, which had not yet entered the coronagraph field of view at the time the discussion was published. Operationally, that phrase has a specific meaning. The Space Weather Prediction Center runs a suite of physics-based models, primarily NLIL, with the more recent Euphoria model now coming online, that simulate the propagation of coronal mass ejections from the Sun through interplanetary space to Earth's orbit. The models require initial conditions: the speed of the CME at coronagraph distance, the direction it is moving, its angular width, the magnetic flux rope orientation, the position of the source region, the surrounding solar wind structure. Some of those parameters are directly measurable from coronagraph imagery. Others have to be inferred from triangulation between LASCO at Earth and Stereo A at its position roughly 90 degrees ahead of Earth in solar orbit. The inference is not perfect, and the longer the modeling team can wait for additional imagery, the better the constraints become. When SWPC writes that modeling is still ongoing, it is telling its operational customers, the power grid operators, the polar aviation routing teams, the satellite operators, the GPS wing, that the published forecast represents the modeling state at the moment of issuance, that the forecast will be updated as new information becomes available, and that operational decisions based on the current forecast should be made with the awareness that revisions are coming. The discussion text is the document where the open questions live. The headline forecast is the document that has to commit to a number. That is the operational tension. The headline says quiet. The discussion says the modeling is not yet finished. Let me give you the published forecast in its own words. The NOAA Space Weather Prediction Center. 3-day forecast issued at 12:30 Universal Time yesterday projects the following. Greatest expected 3-hour KP through June 5th, 3.67. G-scale, 0. The rationale in one sentence reads, no G1 minor or greater geomagnetic storms are expected. That projection covers today and the next 2 days. The radio blackout part of the forecast is performing as designed. The R3 blackout that occurred at 11:28 UTC yesterday, associated with the X1 flare, fell within the 10% R3 probability that the forecast had assigned to each of the next 3 days. The radiation environment, separately, is genuinely quiet. The greater than 10 MeV proton flux is at background, well below the S1 threshold of 10 particle flux units. The position of yesterday's flare source at north 14 west 16 is not optimally connected via the Parker spiral magnetic field structure to Earth's orbit, which limits the proton acceleration that we would otherwise expect from an X-class event. What the published forecast does not yet include is the impact of any of yesterday's 3 Earth-directed CMEs. The headline KP 3.67 projection was made before the modeling for the M9.3 CME, the M7.7 CME, or the X1 CME was complete. The compound interaction with the June 2nd filament, which SWPC has characterized as highly likely, has not been incorporated. The forecast is, by SWPC's own statement, provisional. It will be revised as the modeling completes. The revisions typically come over the next 24 to 48 hours. The compound CME forecasting challenge is not theoretical. Operational forecasters have direct experience from the two largest geomagnetic events of the past several years, both of which involved compound CME interactions that were initially under forecast. The May 2024 G5 geomagnetic storm and the October 2024 G5 geomagnetic storm were the two most intense storms of the past 2 decades. Both events involved compound CME mergers in interplanetary space. Both events were initially issued with headline forecasts in the G2 to G3 range. Both events were revised upward to G4 or G5 as the modeling caught up to the operational timeline. The post-event analyses for both storms documented forecast misses of approximately 1 to 3 kp units on initial issuance, with the headline numbers consistently running below the eventual arrival impact. The pattern that has emerged from the operational experience is that compound CME scenarios produce conservative initial forecasts, with upward revisions issued over the subsequent 24 to 48 hours as the merger geometry becomes clearer in the coronagraph imagery and as the in-situ measurements from the ACE and DSCO-VR spacecraft at the L1 Lagrange point provide direct constraints on the approaching structure. The current week fits the same operational pattern. The headline forecast is conservative. The modeling is in progress. The historical precedent from the two G5 events of 2024 suggests that the published KP 3.67 projection has a non-trivial probability of being revised upward over the next 2 days. Whether the revision lands at G1, G2, or higher depends on the merger geometry, which has not yet been fully characterized. The honest framing is that we do not yet know. The honest framing is that the modeling will resolve over the next 48 hours. The honest framing is that the historical pattern, in the cases that most closely resemble the current setup, is for the eventual impact to exceed the initial headline. Region 4455 is not the only sunspot complex currently producing concerning activity. 4 additional sunspot regions on the visible disk have developed gamma magnetic configurations during the past 24 hours. Region 4458 at South 5 West 8 with 12 spots. Region 4459 at North 14 East 35 with 14 spots. Region 4460 at South 22 West 74 with 6 spots. Region 4461 at South 20 East 57 with 6 spots. A gamma magnetic configuration indicates mixed polarities in close proximity without a clear separation between positive and negative regions. The next step up from gamma is delta, which is the most flare-productive magnetic classification. Gamma regions are the precondition. They are the configurations that, with additional flux emergence, can develop into deltas. SWPC's forecast explicitly names 4 regions: Region 4, 455, Region 4, 458, Region 4461, and Region 4462 as the primary sources of expected M-class and X-class flaring through June 5th. The visible solar disk is currently primed for additional activity beyond the events that have already occurred. If any of the additional regions produces a major flare, while yesterday's 3 CMEs are still in transit to Earth, the operational picture becomes considerably more complex. Additional Earth-directed CMEs, on top of the existing inbound stack, would compound the compound interaction. The probability of that happening over the next several days is not negligible. There is one operational detail from the published documents that the audience deserves to know. The SWPC alert announcing yesterday's X1 flare contains a parenthetical note. Quote, GOES 18 outage, so using GOES 19. End quote. NOAA's primary, GOES East satellite, for X-ray flux monitoring is currently offline. Yesterday's X1 classification was made using GOES 19 as the backup. The measurement is real, well-calibrated, and consistent with multiple independent observational chains, including the Type 4 radio sweep, the 10.7 centimeter radio burst, and the optical observations from ground-based H-alpha telescopes. There is no characterization uncertainty in the X1 classification. What the outage does mean is that the federal space weather monitoring infrastructure is currently relying on a single spacecraft for the X-ray observations that drive the operational flare classifications, with the second spacecraft offline for reasons that NOAA has not publicly elaborated. The system is operating as designed, but the operational redundancy margin is reduced. The largest space weather event of the past several days is being characterized using the backup. The operational picture for the next 48 hours is straightforward to describe. 3 Earth-directed CMEs are in transit. The compound interaction with the June 2nd filament is expected to occur somewhere in interplanetary space between the Sun and Earth, with the merger geometry to be characterized by additional coronagraph imagery as the structures evolve. The leading edge of the merged disturbance is expected to reach the L1 Lagrange point, the position of the ACE and DS-COVR spacecraft, approximately 1.5 million kilometers ahead of Earth, sometime in the next 24 to 36 hours. The in situ measurements at L1 will provide direct constraints on the magnetic field strength, the southward BZ component, and the plasma density of the approaching structure. Those measurements will arrive at Earth approximately 15 to 45 minutes before the disturbance itself reaches the magnetopause, depending on the speed of the structure. If the published KP 3.67 holds, the disturbance arrives as a glancing impact with limited geomagnetic consequence. If the modeling revisions push the KP into G1 or higher territory, the consequences scale accordingly. G1 is auroras visible in the northern tier of states. G2 is auroras visible across the upper Midwest and northern New England. G3 is auroras visible across the Mid-Atlantic. G4 and above push the visible aurora boundary into the southern United States. The May 2024 event produced photographs from Texas and Mexico at G5 intensity. We are not expecting a G5 event from the current setup. We are watching for the gradient between G1 and G3. The Space Weather Prediction Center will issue updated forecasts as the modeling completes. The next scheduled forecast issuance is at 0030 Universal Time. The next discussion text update is at the same time. Both documents will be revised based on the modeling that has been completed in the intervening 12 hours. If the storm arrives at G1 or higher, the visible auroras may be observable from the northern tier of the lower 48 United States tonight or tomorrow night. Northern Maine, northern Minnesota, the upper peninsula of Michigan, northern Washington State, northern North Dakota. The viewing strategy is straightforward. Find a location with a clear view of the northern horizon. Get away from urban light pollution. Look between roughly 10 in the evening and 2 in the morning local time. Modern phone cameras pick up aurora colors better than the naked eye, so even faint displays can be photographed. This is not a guarantee. The auroras depend on the KP arrival level, which depends on the modeling that is not yet completed. But the conditions for visibility from the lower 48 are conditions that the current setup may produce, and viewers in the relevant states should know to look up tonight and tomorrow night. 3 Earth-directed coronal mass ejections from a magnetically reversed sunspot are in transit toward Earth. The published NOAA forecast says, quiet. The discussion text behind the forecast says the modeling is still ongoing. The historical precedent from the 2 G5 events of 2024 shows that compound CME scenarios tend to produce conservative initial forecasts and upward revisions over the subsequent 48 hours. The visible disk is loaded with additional potential flare producers. The primary X-ray monitoring satellite is offline. We will be tracking this as it develops. The next forecast issuance is in the next 12 hours. The next significant data point, the in situ measurements from the L1 Lagrange point, is expected within the next day. The visible answer, whatever form it takes, will arrive at Earth before the end of the week.